I hope you can see my screen. Am I right?
Yes.
Yes, teacher, we can.
Oh, okay, that's good. Okay. Today we are going to discuss chapter 5. What's the title of the chapter? Force and Motion, part 1. So you have two chapters regarding this title, Force and Motion. Chapter 5 is Force and Motion 1, and chapter 6, Force and Motion 2. That means that you have two parts. So you will get a clear picture about these two chapters once we completed chapter 6. So in this chapter, we are going to discuss some important thing, and most important topic from this chapter is nothing but drawing the free body diagram. How to draw the free body diagram. It's very, very, very important. So if you know how to know the force acting on the body, then only you can be able to solve the question. So please, brother, listen this class very carefully. This class you are going to study the basic information about how to draw the free body diagram. So you have to read the question, and from the question you have to understand and you have to draw the diagram regarding what is given on the question. So please listen this class very carefully. So what are the things we are going to discuss today? We are going to discuss the basic definition for force, and then basic definition for mass, and then mass definition we already finished in chapter number 1. And then we are going to study Newton's law of motions. So here we have 3 laws. How many laws we have? How many laws you studied, brother? Three laws. 3 laws you are going to study here, and then we are going to study, apart from that, we are going to study some particular forces. So if you take any object, and how many forces will be acting on that object, so that is very, very important. So this topic and this topic is very, very important. Most probably you will have some definition from this, and some definition from force, and some definition part from the mass. So this chapter is very, very easy, but the most important thing you have to listen here. So here only you are going to study the concept of free body diagram. So it's very, very important, brother. Without knowing the concept of how to draw this free body diagram, you cannot able to solve the problem. So please listen carefully. Okay, let's we start with our first slide, motion. What is motion? And we already studied this definition in chapter number 2. What is motion, brother? It's nothing but if an object position will be changing. For example, initially the object is here, and after some times the object is reaching this this point. So I have 2 points. Initially the object at point A, and then later on, with respect to some time, the object reach the point B. So that means within this time, the object has undergo some movement. Am I right? That is nothing but the motion. So which is nothing but you have 2 points. This is your first point. This is your second point. So you already studied the formula in chapter 2. It's nothing but the displacement. That means x2 minus x1 gives you the information. So that means the change in position of an object with respect to time gives you the information about the motion. So the most important thing when you study the concept of motion, this reference point is very, very important. So first of all, you have to consider what is your reference point. For example, here we just give the information, a stationary object such as tree, street sign, and or line on the road. So you have to keep some references, and that references should be a stationary object. And it should not be. What is the meaning for stationary object? It is not moving. And all the motion is due to force acting on the object. So if you undergo motion, that means some force will be acting on the object. So otherwise it will not move. So in this chapter, we are going to study the concept of force and motion, which is related with some Newton's law of forces. Understand, brother?
Yes.
Okay. Let's we come for the topic of force. What is the definition for force? Define force. Sometimes we may ask the question, what is define force? A push or pull. So for example, you have an object. You have an object on the surface. You have an object on the surface. So suppose this is your object. So you are going to apply some force. So what type of force? Either you have to push or
Pull.
So the push or pull acting on an object, which is nothing but the force. So what is the unit for the force? The unit for the force is nothing but Newton, and another unit for the force is nothing but kilogram meter per second square, because we know the Newton second law. What is Newton second law, brother? F is equal to mass multiplied by acceleration. The unit of mass is nothing but kilogram. The unit of acceleration is meter per second square. So you have to say the unit for force is Newton or kilogram meter per second square. Now, if you just to see the characteristic features of forces, so we already studied in chapter 3 about vector, because force is a vector quantity. It has both direction as well as the magnitude. For example, you consider this diagram. I have an object having the mass m and which is placed on the surface. I am going to apply some force. When I just apply some forces, what will happen? You will have two components, and this is your x component and this is your y component. You already know how to find the component of x and component of y, because we have some formula. So if you want to write the equation in terms of component form, so you have to write f of x. That means my force is acting on x direction, and I cap is the unit cap vector, and then my f of y force is acting on y direction, and the unit vector is nothing but j cap. So here my f of x is f cosine theta, my f of y is f sine theta. You already studied this formula in chapter 3. So this is very, very important. You have to assign, because here they clearly mentioned it must have size. High size is nothing but it represented magnitude, and also it must have some direction. So here the size represented the magnitude, because forces are vector. Now, could you please answer for this question? I have some diagram here, and here the forces, the net forces is the vector sum of all forces of an object, We already studied how to add some vector. I teach you two methods, am I right? One is numerical method, second one is head to tail method. Am I right or not?
Yes, teacher.
Okay, I have 6 pictures here. Out of the 6 pictures, which pictures are right, correct form? And some pictures are wrong, because I already teach you how to add two vectors, head to tail. That means if you have two vectors, I have two vectors, you can see here, I have two vectors, f1 vector and f2 vectors. And this is my resultant vector. Could you please tell me whether this picture is right or wrong?
Wrong, because
Wrong.
Why?
it has
Wrong.
to connect head to tail.
Brother, one by one. Please answer one by one.
Okay, we'll let him go.
Okay, you can just answer now.
Okay, because it's how to connect head to tail.
Very good. So that means this picture is wrong. All right?
Yes.
Okay. What about this picture?
Also wrong.
This is wrong, because here the two vectors, the tail only connected. There is no information about the head to tail, because I already teach you, if you want to add two vectors, the head of the one vector will be connected to the tail of the another vector. So here you can just see, this is my first vector and this is my tail of the first vector, and this is also tail of my second vector. So here this picture is wrong. What about this one?
Yeah, this is correct.
This is correct. So here you can see my f2 vector head is connected with the tail of the second vector, and this is my resultant vector. So this picture is right.
But teacher, one question.
Yes.
But now here it is f2 connected with f1.
No issue. That is not a matter. We have to see only the vector symbol. Okay.
There is no difference. So here.
Yeah, no difference, because only the information is given in the opposite mirror form. You can see this diagram. This is nothing but the mirror form of the picture.
Yes.
Okay. Could you please answer for this one? Yes.
Why number A? It's wrong.
Which one?
A.
You can see, brother, this is my first vector. This is my first vector. This is my second vector. Am I right?
Yes.
You can see first vector tail is connected with the second vector tail. Am I right?
Yes.
So we already teach you in chapter number 3, the head of the first vector should be connected with the tail of the second vector. Am I right?
Yes.
Okay. So according to that, the first two pictures are wrong. My third picture is right. What about the fourth picture?
Right.
Correct. Because here you can see this is my head of the first vector, this is my tail of the second vector, this is my resultant vector. So this is also right. Am I right or not?
Yes.
Okay. What about this one?
Wrong.
Wrong.
How we can say this is wrong? I said this is right. Brother, you can see here I have, you don't confuse about this picture, because here they put the dotted symbol. That means I can move this vector. I can move this vector here. Am I right?
Yes. The sensor.
Am I right or not? Because we already
Yes, you can replace it.
we already, so this picture is right. So please, brother, this dotted symbol is very, very important. So you can shift this vector to the right hand side. By that, you cannot be able to change its magnitude. You cannot be able to change its direction. You can see my magnitude size is exactly the same. My direction is also exactly the same. So my fifth diagram is perfectly correct. Understand?
Again, doctor.
Brother, you can see here. I will just repeat it again. Wait. You can see I have two vectors, F1, F2. Am I right? Am I right?
Yes, you're right.
Okay, you can see here some dotted sign is given. Am I right? Here also some dotted. Here also some dotted is there. Am I right? I am
Yes.
going to move this F1 vector to here. Is it possible?
Yes. You can also move F2 vector.
Yes, of course. Even you can use the F2. You can move this F2. If you just move this F2, it will come here. So, brother, listen
Then
carefully.
it will be correct.
Brother, you can see here F1. If you move the F1 will be like this. If you do this F2, it will be the reverse direction. So it is very, very important. So this is also my F2. This is also my F2. This is my F1 and this is my F1. So this picture is perfectly correct.
Doctor,
Yes.
if we have a separate line, that means it's always correct.
The most important thing, you have to see the arrow mark. Suppose if this arrow mark will be here, what happened?
What? You don't
Suppose
understand.
because this is the arrow mark. Am I right? This is my arrow mark. Am I right? If my arrow mark will be here, what will be the answer?
Wrong, because the other side will be the head with the head.
The head of the tail vector is connected, but what about the resultant vector? You can see the direction of the resultant vector. This is very, very important. If your arrow marks will be here, you can see this diagram. I have this diagram, but my arrow mark will be here, and this is my second vector, no issue, it's right. But you can see my resultant vector is in this direction. So if you have the resultant vector in this direction, it is wrong. If you have to get the resultant vector like this. Clear?
Yes.
Okay. So your yes, brother.
C. We have head with head in F1. C and
Okay.
the R.
Third one.
Yes. Number C.
Okay, you can, yeah, because this is my head, this is my tail. This is my head of this vector. This is my tail of this vector. So it is right.
Okay, it's right. But in the top.
This one,
See?
this one,
Yeah.
this one, this is a resultant vector, brother. This is a resultant vector. That means my resultant vector, which is nothing but F1 plus F2. This is your
No
resultant
problem.
vector.
Head with head.
Brother, this is a resultant vector. You have to consider only F1 and F2. And the resultant vector should be here only.
Okay.
Understand?
Understand.
Okay. Could you please answer for this question? What about the answer for the last one?
It is correct.
It is correct or wrong? Just to see the
Correct.
resultant vector.
Wrong,
See
wrong.
the resultant
Wrong,
vector
wrong.
arrow mark. So this picture is wrong. So out of the 6 pictures, only 3 pictures are right and 3 pictures are wrong. Understand? So yes, brother.
F is wrong because the arrow down, right?
Yeah, if the arrow will be here, it is perfectly correct.
Okay.
Clear?
Yes, clear.
Okay.
So,
So
Doctor, I have a
sometimes,
question. If I move F1 to the right side, does it
okay.
make it
So,
right?
so you,
If
if you want to, brother, if you want to move F1 here, but what is your arrow mark? This is very, very important. Where is your arrow mark? Even if you move F1 here, what is your arrow mark? It is totally wrong. That's what this picture is wrong.
if it is down, it's wrong.
Yeah. Because my first vector head is here, my tail of the second vector here. So my resultant vector should be in this direction. But here you can see it is pointing downward direction. Am I right?
Yes.
So
Teacher,
this picture. Excuse me, brother. Yes, please.
E wrong, right?
E is correct.
I don't understand properly.
Brother, this topic we already studied in chapter number 3. If you just say like this is not good. And right now we are in chapter number 5. You are asking the question from chapter number 3. Okay, you can just see here.
I know if
No problem. Okay, listen here, brother. This is my first vector. So this is my first vector head. This is my first vector tail. Am I right?
Okay.
My second vector tail is this. My second vector head is this. Am I right?
Okay.
And the dotted symbol is given. So I can move this F1 to the right hand side. Is it possible or not?
Yes, possible.
So now you can see, forget about this F1. Now this is my F1. So you can see my head of the second vector is connecting with the tail of the first vector. Am I right?
Okay.
So my resultant vector is this. So R, which is equal to F1 plus F2. So this picture is correct.
Or F2 up.
If you want to move F2 means no issue. It is also right.
Yes, okay. I understand
So
now.
if you want to move F2 here, then you have to consider this is your F1, this is your F2. Clear?
Yes, teacher.
Okay. Okay, let's come for the basic information about the net force. So if you want to add the net force, for example, I have two forces. What is given here? Two scenarios are given here. Is for easy calculation. You can just read the first point. If the forces are moving in the same direction, what you have to do? You have to add these together. Suppose I have two forces, one is moving on the right hand side, one is moving on the left hand side. By the time, what you have to do? You have to subtract. Understand? I gave some example here. You can see this picture, then you will understand these two scenarios. Understand? You can see the first scenarios. I have a musical instrument here. I am applying two forces on the same direction. Which direction it is moving? It is moving in which direction you are applying the force?
Left.
So my 15 Newton is also left. My 30 Newton force is also left. Am I right? So both are moving in the same direction. So what you have to do? If both forces are moving in the same direction, what you have to do? Add. So 15 plus 30 gives you
45.
45. And which direction? Because it's a vector quantity. Which direction it is moving? Left direction. Okay, let's become for the second. Okay, let's become for the second. I have the musical instrument here. One force is acting on the right direction, and another force is acting on the left direction. And this force is the greater force, and this force the smaller force. Am I right?
Yes.
So both are moving opposite direction. So what you have to do? You can just go and see the second point. If both forces are acting on opposite direction, what you have to do? You have to subtract. So if you subtract 30 from 15, what should be the answer? 15. And the most important, this force is the greater force. Am I right?
Yes.
So right direction. So this is very, very important. This indicates my magnitude. This indicates my direction. Clear, brother? So that information are given here.
Yes, clear.
Okay. Now let's come for the topic of mass, because if object is moving means the object must have some mass. That means the mass is the amount of matter in the body, how much quantity it have in the body, and then the mass of the body is the characteristics that relate the force of the body to the resultant acceleration. For example, you can see I have an object here, and now this object is under motion. So I am going to apply the force in this direction. So my object will be moving in this direction. At the same time, what will happen? It must have some acceleration. So the mass is very, very important characteristics related with the acceleration. It's very, very important. You can just see our mass is a scalar quantity. What is the meaning for scalar quantity? Is there any direction is given for mass?
No.
No, because mass is a scalar quantity. It must have only the magnitude. You can see here, I gave one example. Apply 8 Newton force to various body. So now you can see here, my force is 8 Newton. And what is my mass? My mass is the 2 kilogram. Am I right? Am I right?
Yes.
Okay, how
Yes.
to calculate the acceleration? You already studied this formula in your school. F is equal to mass multiplied by acceleration, which is nothing but it is Newton's second law. So from this formula, I'm going to take the acceleration. So therefore, my A is equal to F over M. Am I right? What is my F? My F is 8 Newton. My M is 2 Newton.
2
So
kilogram.
you can just see here, which is nothing but 4 meter per second square. Clear?
Clear.
So you can see here, my mass has the direct some relation with the acceleration. If mass will be increased, my acceleration will decrease. If mass will be smaller, my acceleration will be the greater. So it has the inverse relation. So our mass has the relation with the acceleration, and it is the inverse relation with the mass. Understand, brother?
Yes, understand.
Okay. Now let's we come for the Newton's law of motion. You already studied these laws in your school life. I want to repeat the same thing again. How many laws you have? You have 3 laws. The Newton's first law, and Newton's first law is also called as law of inertia. And we have another law, Newton's second law. And here you already familiar with the formula F is equal to m into A. And then we have third rule, Newton's third law. And we have another name for this third law as action and reaction. What is the meaning for action reaction, brother?
Every action has a reaction.
Every action has
Same-
its equal and opposite reaction.
Same power,
Direction.
opposite direction.
Yes, same magnitude, but the reaction, the direction will be in the opposite direction. So you have 3 formulas. Out of these 3 formulas, only the second formula has some formula which is nothing but force, which is equal to mass multiplied by acceleration. Now we are going to study the definition for the 3 losses. What is the definition? Sometimes we may ask this in your theory question. Define Newton's first law of motion. So what is written here? You can just read this, brother. You will get a clear picture. An object once in motion will remain in motion along a straight line. For example, you can see the car is moving in one direction. So at a constant speed. And then the object at rest will remain at rest. For example, forget about this diagram. I can just give an example of the football. So I have a football here. Initially, what is the speed of this football, brother? What is the velocity of the football?
0.
0.
Zero.
That means before you apply the force, my object remains at the same position. That means my object is at rest. Am I right or not?
Yes.
Now you come and kick this ball. What will happen? The object will
Move.
Accelerate.
move.
Will
That
move,
means, brother, the object will move. When you apply the force on that object, the object will continue to move. But the most important thing, you must not have the friction. If there is no friction, air friction, the object will keep on moving. If there is a friction, the object will move, but later on it will stop. So the most important thing, when the object is at rest, the object remains at rest. When you apply the force to the object keep on moving. So that is nothing but your first law of motion. Understand, brother?
Yes.
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 Okay, let's become for our second law. Second law, I already told you, we have the formula F is equal to F is equal to mass multiplied by acceleration. Our F is the unit vector quantity, and mass is the scalar quantity, and acceleration is the vector quantity. So here we must have the mass as well as the acceleration. What is the definition for Newton's second law of force? You have to write. Brother, if you ask this question, better you can do one thing. Write the formula, explain each and every term. My F is the force, net force. M is the mass of an object. A is the acceleration of an object. You can write like this. Suppose if you cannot be able to make sentence like this, you can write the formula and then you can explain each and every term. Understand?
Yes.
Okay, so this is the definition. My net force of an object is equal to the product. What is the meaning for product? That means the product is nothing but the multiplication form. What is the product? Mass multiplied by acceleration gives you the force. Understand?
Understand.
Okay.
Yes, understand.
Let's we come for our third law, Newton's third law of motion. I already told you it has the another name, law of action and reaction. You can see here, brother, for every action force, whenever you are applying any action, what will happen? There is an equal in magnitude, but what is the direction? Your direction will be acting the opposite direction. So for every action, there must be equal and opposite reaction force. For example, you can see the car. The car is exactly over on the road. You can see the tire is pushing the car forward direction, but the road is pushing the tire, but the tire pushes the road action, and the road pushes the tire is a reaction. Then only your car will be moving. Otherwise, what will happen? Your car will not move. For example, you can see this diagram. The person is just stretching the spring. That means that he is applying some force here. When he just leave, what will happen? It will have some reaction. For example, you can take a ball. You throw the ball to the wall. What will happen? When you just throw the ball to the wall, what will happen? It will
It
just
will return to you.
What, brother?
It will return to you.
It will be returned back. So your magnitude remains the same, but the action will be acting on the opposite direction. So it's one of the important laws. Sometimes we may ask this question in your theory question. Understand?
No, yes.
Yes.
Okay. Now this is a very, very important thing. Some
Doctor.
forces. Yes.
We study already if it's the direction it's opposite, we make subtract, right?
Yeah. So you have to put minus symbol.
Yeah, okay. Why the third Newton said it's same magnitude?
Because of whatever the force you are going to apply, it will be come back with the same force. If there is no air resistance.
Okay, but it's different direction, I think.
But direction is only different. But what about the magnitude?
Why we don't make subtract?
Brother, you are not going to subtract. You can see here, the formula will be like this. Force action. That means you are going to give some action force. What is your reaction? Minus of. Understand?
Okay.
It will be like this. If you want to write the definite equation form, this will be the rightest form. Understand?
Understand.
Okay. Let me come for this topic. This is our last slide. We are going to study some important forces. What are the forces you are going to study? We are going to study applied force. We are going to study gravitational force. We are going to study normal force, frictional force, air resistant force, tension force, spring force. What are these, brother? For example, you can see these slides. I gave some diagrams. Am I right? Am I right or not? How many diagrams I gave? I gave diagram 1, 2, 3, 4, 5, 6 pictures I have. Am I right or not? Am I right?
You're right.
Okay, let's we come for this diagram. We will start from this diagram. Brother, how many forces is acting? My object is exactly over the surface. Brother, listen carefully. Okay, better we start from here. That will be quite good. Okay, this is my first picture. Forget about this. I will come later. Okay, you can see this. I have an object on the table, and the object is exactly at rest. If any object is at rest, how many forces is exactly acting on the object?
2.
2 forces. That means one force is exactly in the upward direction, which is called as normal force, and another force is due to the gravitational force. That means this object is at rest. When any object is rest, if you want to maintain the equilibrium, you must have two forces. One force is exactly acting on the upward direction. Brother, the most important thing, always your normal force will be perpendicular to the object. What is the meaning for the perpendicular? For example, I have an object here. What is my perpendicular? Normal. This is my perpendicular. Am I right?
Yes.
So for example, I have an object like this. This is my road. I have an object here. So what is your normal force? Perpendicular to the object. So this is my normal force. Clear? So you have to see the very important thing, the level where the object is exactly sitting. So in this picture, my object is exactly sitting on the horizontal table. So I have two forces. My perpendicular force acting on the object is exactly called as normal force, and then my downward force is nothing but the force due to the gravitation. So in this picture, I have two forces, normal force as well as the gravitational force. Now you come for this picture. I have an object exactly on the surface. You can just see I am going to apply the force in this direction. I'm going to apply the force in this direction. So when I just apply the force in this direction, what will happen? This object will have the acceleration in this direction. Am I right?
Yes.
Okay, when the object is moving, you have some frictional force between this layer and the object layer. So my frictional force always acting on the opposite direction. This is my frictional force. So my applied force. So always your friction force will be acting opposite to the applied force. So this is my applied force. So what is my applied force? This is my applied force. This is my frictional force.
Fractional force.
Clear?
Yes.
I can do one thing. Better I can just open one more slides here. Then only I can just write something over here. You will get some idea. Okay. Okay. Now, see here, first picture what we studied. We have an object exactly sitting on the table. So how many forces acting? My perpendicular force is nothing but my normal force. Normal force should be indicated with the letter F suffix N. That means normal force. And then another force will be downward direction, which is nothing but my force due to gravity. And the second picture, I have an object, and now in this object,
The first one you mean you pull it up, right?
What, brother?
The first force, Fn, you pull it up.
Yes, it's always perpendicular to the object. It always perpendicular to the object. This is my object. This is my perpendicular. What is the meaning of perpendicular? It's 90 degree. Am I right? Okay. Now in the second picture, I have an object. It's exactly on the surface, and this surface, this is my surface, and I'm going to apply the force in this direction. That means my object will be moving in this direction. So this is my applied force. So when you apply force on an object, always the frictional force will be acting opposite direction. So this is my frictional force. Your frictional force always acting on the opposite direction. That information is given in the second picture. Suppose, let's we come for our third picture. What is our third picture, brother? You can see my object is exactly sitting on the inclined plane. My object is exactly sitting on the inclined plane. What is meaning for inclined plane? I have the surface, this is my ground level, and then I have a inclined plane with certain angle. So this is my angle. Now my object is sitting here. So what is the, how many forces is acting, brother? One force is upward force, that is nothing but normal force perpendicular to the object. Am I right?
Forces.
Am I right? Am I right or not?
Yes, F normal.
Okay. So this is nothing but my normal force, and my force due to gravity will be in this direction. Am I right? So this is my gravity force. And then apart from that, because here you place an object with some angle, brother, you can just extend these, our x component and y component. This is my x component because this is my angle. So whatever the angle you put, this angle will be coming here. So this is my f component, which is nothing but cosine component, and this is my sine component. So how many forces is acting here? You can see here, my gravitational force is nothing but mg. That is nothing but my mg cosine theta, because you placed an object exactly with respect to some angle. So this angle, which is equal to this angle. Am I right or not? Am I
You're right,
or not?
teacher. You're right.
Okay, so you have two components, x component and y component. And apart from that, you have two more forces, normal force as well as the gravity force. So please, brother, the most important thing, you must know how to draw the diagram. This is called as free body diagram. Free body diagram represented how many forces will be acting on an object. So where you are going to keep the object. So based on the position of the object, how many forces is acting. This is very, very important. Okay, let's come for this diagram. Let's come for this diagram. I have an object. I have an object. And this object is connected with a rope. This object is connected with a rope. And I'm going to pull this rope in this direction. So this is my rope. I'm going to move this object in this direction. That means my applied force will be in this direction. So my applied force will be in this direction. When you apply the force in this direction, some tension will be created. Am I right? So this is my rope. That means what is that? The tension. My tension force is nothing but I am applying the force in this direction. So my tension force will be created in this direction. And this is my applied tension. This is my applied tension. This is the tension of the rope. Clear?
What does this T tension?
T means whenever you have the string rope, then you should not indicate it with the letter F. So you have to replace this F with tension. Clear? So this tension is only applicable for the.
T?
It's one tension. Tension.
Friction or what?
Tension is only for rope, string. Okay. When you have any rope or string, the force acting on the rope and the string is called as tensional force. Clear? You can see this diagram. You can see this diagram. I have an object. The object is connected with a rope, and you are pulling. You are just pulling the force. So when you just pulling the force, that means the object force will be in this direction, and then tension will be created on the rope. And this is your applied tension on the rope. This is the tension of the. Clear, brother? Clear?
Yes, teacher.
No. No, not clear.
Wait. Okay, you can see this diagram. You can see this diagram.
Yes.
I have a mass. This is my mass of an object, and this mass of an object is connected with a rope. And this is your hand. You can consider this is your hand. You are just pulling this object in this direction. Am I right?
Yes.
Yes.
To the right.
So you're just going to apply the force. That means this is my applied force. My applied force is in the right direction. So when you apply the force in the right direction, what will be happen in the string? What will be happen in the string? The string will have some tension force. So you have the tension force. So this is my applied force direction, and this is the tension force. Brother, what is this? Action, which is equal to minus of reaction. My Newton's third law.
Doctor, always the magnitude is 0, right?
What is 0? How the if the magnitude is 0, how you can
About
say it is magnitude?
About the third ruler of Newton.
Brother, magnitude, brother, you have the same magnitude. Right hand side also have the same magnitude. Left hand side also have the same magnitude. Only the direction is different. Here, what is my direction? Positive. What is the direction here?
Negative.
Negative. For example, I applied 4 Newton left hand side, 4 Newton right hand side. That means my magnitude on both sides will be the same, but only the direction is different. Understand?
Understand, but when we calculate the force, it's 0, right?
It will be cancelled out.
Yeah, 0 mean.
Okay. So, but in general, you can just consider it in point of the equation. Okay.
Doctor, 1 second. You mean in this that you draw, we have two forces: the force of the apply and the second force of tension. Tension, you mean by it friction?
Tension means the tension, the force acting on the rope. The force acting on the rope. Brother, friction will be here. Not your friction will not be here. Your friction only will be here. Your friction only will be here. Understand?
Okay, what does tension mean then?
It's a force acting on only the rope. If you have the rope and the string, only the force acting on the rope is called as tension. That's what I just written here. When you have the rope
I
and
know
string,
that means we have only one
ناصر why not
force
the one
in the right direction, not in the left. Another one.
brother, this is the applied tension. Okay. Better I can just draw because I cannot able to I cannot able to draw my hand symbol. Huh? You have a rope. Okay, this is my rope. You are pulling the rope in this direction. That means the tension will be in this direction. Am I right? And at the same time, your hand will be pull this object to the right hand side, and the rope will be pulled this left hand side. So the force acting on the rope is called as tension.
I understood.
Clear? So likewise, you can see this diagram. You can see this diagram. I have a pulley. This is called as pulley, and I have a block here, and the block is connected with the rope, and it is passing through the pulley. And in another end, I am just holding the rope. Now I am going to pull this rope in the downward direction. So in the downward direction, I have the force due to gravity. Am I right? And upward, because this is a rope. What is my force? My force is called as tension. And likewise, here also I have string. My tension will be in this direction. Clear? Don't get confused about the word tension and the force. Brother, force and tension are exactly the same, but the tension is only given only for the string and the rope. Keep this information in your point.
Doctor, the second tension,
Okay.
why the direction it's not down?
My direction downward is
Because
nothing but my brother, listen
تتحرك
carefully.
يمين ايه تسحبها من تحت تتحرك يمين.
So brother, listen carefully. I have a surface here. This is my object. Here I have pulley. I am just pulling this direction. So here, when you just pull, what will happen? The downward direction is called as force due to gravity. My upward force is called as tension. Clear?
okay.
Clear. So because I have a string here, so always the downward force is called as gravitational force, and the upward force on the string is nothing but the tension. And here also I have the string, so here also I have some tension. Clear? So wherever you have a string or a rope, then you have to represent the force acting on the string and rope is called as tension. Keep this information. You should not use this tension for the remaining case. The tension is only applicable for the rope. Clear?
Clear.
Okay. So based on these diagrams, and this is called as a spring force. I have a spring here. When you just apply some mass, what will happen? The string will be elongated. Am I right or not? I have a string here.
Yes.
Yes,
I
yes.
have a spring here. I have a spring here. Initially there is no mass. When I apply the mass, what will happen? It will be elongated. So you can see how much distance it is elongated. It will be displayed to some distance x. So here also the point information about the compression and the contraction, compression and relaxation. Here is compression, here is the relaxation. So compression means there is no applied force. And here when you apply the force, it will be extended to some distance. So all these forces we are going to use in the problem. When you're just about to solve the problem, by the time it will be easy for you. Clear?
Teacher, can you please repeat the spring?
Okay. You have a spring. Sorry. You have a spring here. Okay. This is my spring. Clear, brother?
Okay.
So now I'm going to apply some mass to the spring. That means when you apply some mass, what will happen? My spring will be like this. Am I right?
Yes.
How much distance it is displayed? It displayed at a distance of S or X. So this much distance it is elongated. Am I right? Initially, this is my position. This is my length of the spring. After I attach the mass, what will happen? It will be increased in this distance. Am I right or not? So this is my
Yes.
force due to gravity. My upward force will be in this direction. Clear?
Okay. Yes. Yes. Clear.
Clear? Okay. Now, brother, these are all the 5 problems. You should listen very carefully. It's very, very, very important problems. And if you know how to solve that, and the remaining chapters, especially chapter 12, will be easy for you. Understand? Okay. Let's read the first question. What is given in the first question? A body has an acceleration. So better I can just write the given first. What are the things given here? The body has an acceleration. My
The acceleration
my,
3
okay,
meter per second.
Brother, listen carefully. My acceleration is a vector quantity or a scalar quantity?
Acceleration, of
Vector.
course, it's vector.
It's a vector quantity. Am I right? It's a vector quantity.
Yes.
That means you can consider an object is here. This object has some acceleration, and the acceleration magnitude is given. This is our magnitude. Am I right? So this is my acceleration, which has the magnitude of 3 meter per second square. So if you have this acceleration, you must have x component and y component. Am I right or not?
And angle.
Okay, and also
Yes.
the most important thing, the angle. So what is given here? The magnitude of the acceleration is given as 3 meter per second square. And then angle is given. What is that angle? What's the
30
angle?
degree.
30 degree. And then mass of an object is given. What is the mass of an object? 2 kilograms.
2 kilogram.
Now,
2 kilogram.
what you are going to find? You are going to find
The force.
x component and y component of the net force. So if you want to calculate this net force, you have to apply the Newton's second law. What is Newton's second law, brother? My Newton's second law is F is equal to m into A. Am I right?
Yes.
Yes.
So I am going to apply this Newton's second law, but the most important thing, you have to find for x component, and then you have to find for y component. Am I right?
Of course.
So better what I'm going to do, first I'm going to find my x component. What is my x component, brother? Just recall the topic what we studied in chapter number 3. My x component, which is nothing but magnitude of cosine theta. Am I right?
Of course.
So my magnitude of this acceleration is 3. My cosine theta is nothing but 30 degree. So if you just apply, what will be the answer? My answer will be 3 cosine of
out of 3
30.
over 2.
So that means 3 root 3 over 2, which is nothing but which is equal to
2.6.
which is equal to
2.6. 2.6. 2.59.
2.598 I can write. Okay, the unit is meter per second
Yes.
square. Understand?
Yes.
Clear? Okay, once I found these things, I'm going to find my x component of the force. What is my x component of the force? My x component of the force, which is nothing but mass multiplied by the acceleration in terms of x component, which is nothing but my mass is 2 kilogram. My acceleration is, what is my acceleration? 2.598
598 meter per second.
meter per second square. Am I right? So multiply by 2 gives you the answer of 5.19. So 5.196. What's the unit? Newton. Clear?
Newton. Yes,
Clear?
clear.
Okay. And likewise, I'm going to find my y component. What is my y component, brother? My y component, which is nothing but magnitude of A, sine of theta.
Sine.
My magnitude is 3, sine of 30 degree. So 3 sine of 30 degree gives you exactly 1.5. So our answer is 1.5 meter per second square. So I'm going to find my y component, which is nothing but A multiplied by, so mass multiplied by A of y. My mass is 2 kilogram, and then my acceleration of y component is nothing but 1.5 meter per second square. So which gives you 3
Newton.
3 Newton.
3 Newton. Now, what you have to give the answer? The answer is very, very important. You can see here, we find our x component, we find the y component. This is my x component. This is my y component. Am I right? Sorry, this is my y component. But what is the third question? What you have to find?
What is the net force in unity vector notation?
In unit vector notation, that means my force, which is nothing but f of x I cap plus f of y j cap. Am I right? So what is my f of x? What is f of x?
5.196.
5.196 Newton I cap. What is my
I
f
cap.
of y? 3 Newton.
Newton J cap.
So this will be the answer. Clear?
Yes.
So answer is given here.
Yes.
You can just work out very carefully. Understand, brother?
Yep, teacher. It's
Okay.
very easy. Simple
It's
question.
very, brother, you will make big mistake only the easiest question. Don't say like this, huh? All the students
Yes,
you will
of course.
Yes,
you have
because
to.
they say
I have to
this
practice on this.
question is very
see here. What are the mistakes the students they will do? You know, they forget to write the unit. They forget to write in terms of I cap and J cap, the unit of acceleration. So these are all the mistakes. You will lose some marks for these things. Understand?
Teacher, what about if I write the I without the cap?
Okay, no problem. But try to avoid that. Okay, because cap is very because the cap means unit vector. The meaning is nothing but the unit vector. If you don't put the cap, means it is different. It's totally different.
Yes.
Clear? Don't
get
forget to put the cap. Okay. Let's come for the
I will.
second question. Brother, second question. You can see the picture and then you have to give the answer. Please listen carefully. I have the picture here. Could you please draw the force diagram here? Brother, could you please draw the force diagram? I have an object of having the mass m. It is exactly placed in the inclined plane of an angle theta. What is my theta here? My theta is given here. What is the theta? What are the things given here? My 30 degree is my theta. And what is the mass of an object? My mass of an object is
8.5.
8.5 kilogram. Okay, now what are the things you are going to find? What are the things you are going to find? You are going to find the tension in the cord. Cord is nothing but the rope. Brother, this is called as cord. Cord is called as rope. Okay, so that means we are going to find the tension happened in the cord. So we are going to find the tension in the first question. And what you are going to find in the second question? You are going to find the normal force. Am I right? Am I right?
Yes.
And what you are going to find in the third question? You are going to find the acceleration. So, brother, if you want to find the tension, if you want to find the normal force and acceleration, first you have to draw the free body diagram. Brother, listen carefully. Could you please go to the previous slide? Your picture is like this, am I right? Your picture is like this, am I right? Am I right or not? Just
Yes,
answer me.
teacher.
So how many forces will be acting on this diagram? One force upward, gravitational force downward. Apart from that, I have x component, y component. So how many forces we have?
5.
5 forces. Better we can just write these things. So this is my normal force. Am I right? This is my
Gravity
normal
force.
force, and this is my force due to gravity.
Force.
That is nothing but F of G, which is equal to mg formula. Am I right?
Tension.
And this is my x component force, which is nothing but mg cosine theta, and this is my g
Y component or
sine theta. Clear?
and tension.
Tension. This is nothing but our tension. Clear?
Yes, quite clear.
So, brother, you have to first draw this diagram. If you don't draw the diagram, you cannot be able to get this tension, normal force, and the acceleration. Okay, let's come for the first question. What is our first question? We are going to find the tension. Am I right? Brother, if you want to find the tension, you have to see this is my y coordinate, this is my x component. So, if you want to find the tension, brother, listen carefully. You have to consider only these forces. Only these forces. Clear? Clear?
Yes, quite clear.
So my first question, my tension, which is equal to mg sine theta, my right hand force, which is equal to my left hand force. Am I right? Am I right or not? My right hand force is tension. My left hand side force is mg sine theta. Clear?
Yes.
Yes, clear.
Now apply the rule. So mg, what's the value of m? 8.5. G value 9.81. Sine of what is my theta? 30 degree.
30
So what will
degree.
be the answer? What will
30
be the answer?
4.25.
8.5 multiplied by 9.81
4.25.
multiplied by, wait, I will check again. Sine of, so what you got?
41.69.
41.69 Newton. The unit of tension is Newton. So this will be the answer for the first question. Understand?
Yes.
Yes.
Okay. Second question. What you are going to find? Second question.
The normal
What you are going
force
to find?
acting on
What
the
you are,
block.
The normal
okay, so
force
that,
acting on
that means normal force you are going to find. Am I right? So if you want to find the normal force, your normal force is exactly perpendicular. Am I right?
Yes.
So I have to consider only these forces, my perpendicular force. mg cosine theta. Clear? My upward
yes.
force, which is equal to downward force. My upward force here in the diagram is Fn. My downward force is nothing but mg cosine theta. So I can just write like this. If you substitute the value, my mass is 8.5, my g value is 9.81, and then cosine of 30 degrees. So what will be the answer?
72.21 Newton.
How much?
72.21
Okay,
21
21 Newton.
Newton.
So we got the answer for the second question. Am I right? Am I right?
Yes.
Okay, wait. I can just
Yes.
erase
Now
this.
see.
Okay, now we go.
Always normal force mg cosine theta.
Brother, you should not, you have to see the picture first, brother. You should not say like this. You have to see the picture first. My normal force here, this is my upward force. This is my downward force. Am I right? My upward force, which is equal to downward force. So you have to
Yeah.
consider only these forces. You should not consider the horizontal force. You have to consider only the vertical force. Clear?
Yes, yes.
Okay. Let's we come for, I just erase this and then we'll go for the third question. What is given in the third question? Read the third question. If the cord is cut, brother, here you can see the diagram. We connected the block with the rope to this wall. Am I right? We attached here. Am I right or not? Am I right?
Yes.
What? I didn't hear you, teacher.
Brother, I have the mass, and the mass is connected with a rope, and another end of the rope is attached to the wall. Am I right? This is my wall. Am I right?
Yes.
So now what I'm going to, I'm going to cut this rope. If you cut the rope, what will
the
happen? Minus mg sine theta. Am I right?
Yes.
Am I right or not? So this mass and this mass get cancelled. My acceleration, which is equal to minus g sine theta. Am I right?
Yes.
Yes, yes.
Am I right or not? So
Yes.
therefore, minus 9.81 sine of 30 degree. What's the answer?
Minus
Minus 4.90.
sine
Okay, minus
90.
4.90. What's the unit?
M per second square.
Okay, but what they ask in your question? Find the magnitude. What is the meaning
The
for
magnitude.
magnitude, brother? Only the
The
positive
absolute
answer.
value
The
of
magnitude is
the
nothing but
acceleration.
yes, right. Perfect. Clear?
Yes, clear.
Clear, brother? Brother, this is one of the important question we asked many times in the exam. So please, the most important thing, you must know how to draw the force acting on the objects. The diagram is very, very important because you are framing this equation, only from the diagram. Am I right or not?
Yes, Doctor, I have a question.
Yes.
If the acceleration is given, I can find the, you can see this mg sine theta. I write instead ma sine theta, right?
Here.
We have
What you are
two
saying?
mg cosine theta and
Brother, listen carefully. Brother,
uh,
if you cut this rope, in which direction the object
I'm
is
not talking
accelerating?
about rope. I got the rough idea, Doctor. I'm talking about this mg sine theta.
My dear, first of all,
mg
please
sine
listen here.
theta. I have the
Please,
acceleration giving. I write it as ga, right?
excuse me, first you listen here. Okay. When you cut the rope, what will happen? The object has the acceleration only in sine component. Am I right?
Yes.
Am I right or not? Is there any acceleration?
Yes,
Is there any acceleration in the cosine component? No acceleration. So forget about your x component. Only y component has the acceleration. Am I right?
Yes.
So my Newton's second law is nothing but mass into acceleration, which is nothing but minus mg sine theta. Because my mg sine theta, my acceleration is there. This mass and this mass get cancelled. Finally, I have
Doctor,
a is equal to minus. Clear?
Doctor, I know this is not my question.
What's your question?
I said we have two, mg
Yes.
cosine theta and mg sine theta, right?
Yes.
If the acceleration is given, we replace the g by a, right? But this is my question.
Brother, you should not replace the a. Brother, I think you will get confused about your practical and the theory. Am I right?
No, go to the back question, Doctor. You will ma, not mg sine.
Okay, let's come for the equation. You can see here. What is your Newton's second law, brother? What is your Newton's second law?
And Newton's second law, this force
My
equal
Newton's m into a. Am I right?
yes.
When you cut this rope, my object is accelerating only the y component. Am I right? Am I right?
Yes, you are right.
So my acceleration of my force is acting on this. Am I right? Am I right or not?
Yes.
Now you can see my left hand side of the
Yes.
equation is 4, so I can equate these two. Am I right? Am I right? I can write like this. Am I right? This mass and this mass
Yes.
get cancelled.
It
Finally, A is
has
equal
A
to
equal minus B sine theta.
clear. So
Clear.
here you have acceleration is equal to g sine. Understand?
Understood.
Okay. So answer is given here. Please take a practice. It's very, very important. Clear? Okay. Let's come for our third question. Brother, third question is very big size, but it is very easy. So please read the question very carefully. Please read the question very carefully. Understand? Could you please read the question? A car that weighs 1.30 10 to the power of 4 Newton. That means the weight of the car is given. Given. What are the things given in the question? The weight of the car is given. What is the weight? 1.30 multiplied by 10 to the power of 4 Newton. Is initially moving with a speed of 35 kilometers per hour. That means initially. What is the meaning for initially? Initially means it's clearly mentioned about initial speed. So what is my initial speed? My initial speed, which is equal to 35 kilometer per hour. Brother, I have to convert this kilometer in terms of meter. I have to convert this hours in terms of seconds. So how I can convert? 1 kilometer is equal to how many meter? 1000 meter.
Yes.
Am I right? Likewise, 1 hour, which is equal to 60 minutes multiplied by 60 seconds. Am I right?
Yes. Yes.
So I can, when you just work out these things, what will happen? You will get the initial speed in terms of meter per second is 9.72 meter per second. Am I right?
Yes.
So this is my initial speed in terms of meter per second. Okay, let's keep on continue reading this question. When you apply the brake, the car is about to stop. So when the car is about to stop, what is your final velocity? What is your final velocity?
0.
It's 0 meter per second. And how much distance is covered? The distance covered is nothing but
15 seconds. 50 meter.
15 meter. Understand? Now,
Yes.
these are all the information given in the question. We just going to find 4 answers. 4 answers you have to find: A, B, C, and D. We start with the A. Assuming the force that stops the car is constant, find the magnitude of the force. So that means what you are going to find the first answer. You are going to find the
magnitude of the force.
magnitude of the force. Am I right? Magnitude. That means because why they are just saying magnitude? Here you will get the magnitude in terms of negative answer, because you are just initially moving with a speed of 9.72 meter per second. When you apply the brake, what will happen? Your speed get decreased, so your acceleration get decreased. Am I right?
Yes, of course.
So your acceleration value will be negative here. Am I right or not?
Yes.
Yes,
So
kid.
if
It's
you want-
deceleration, not
want-
acceleration.
It's a deceleration.
Yes.
Am I right?
Yep.
Okay, so if you want to find force, we know the formula for the force. What is the formula for the force, brother? Mass multiplied by acceleration. Am I right?
Yes, but we
So-
don't know, we don't have an acceleration now.
That's what. Listen here. So if you want to find the force, you first find the mass and acceleration. Once you find these two, you can find the magnitude of the force. Am I right?
Yes, of course.
Okay, first I'm going to find the mass. So what I'm going to do? First I'm going to find the mass. Finding the mass, weight is given. Am I right? So we know the formula. Weight is nothing but mass multiplied by gravity. Am I right?
Yes.
Therefore, mass is equal to weight over g. Am I right?
Yes.
My weight is 1.3 multiplied by 10 to the power of 4. My gravity is 9.8. When you just work out these things, what you will get? My mass, which is equal to 1327 kilogram. So I can just write these as 1.32 multiplied by 10 to the power of 3 kilogram. Clear?
I said leave it as the first one. It's
Okay,
good.
no problem. No problem.
1327.
Brother,
is
it's
easier.
up to you. No issue. Okay. Okay. So
Thank
we
you.
find the mass. Second thing, we are going to find the acceleration. For finding
Yeah.
the acceleration, I'm going to pick the third equation. What is our third equation, brother? Just recall the third equation. What is our third equation? Our third equation is v square, which is equal to v naught square
V naught square
2 into
plus
a to x minus x naught. Am I right?
yes.
Our x minus x naught is nothing but here. This is our
It's
x minus
15
x naught.
meter.
Am I right? Okay.
Yes.
This is our x minus x naught. So what is my initial speed? My initial speed is 0. What is my final speed? 9. Sorry. My final speed is
You
0.
replace it, teacher.
So this is 9.72 square plus 2 into a into my distance covered is 15 meter.
15.
Am I right?
Yes.
Now I am going to move this term to the left hand side, or I can just move these things. So what you will get? My acceleration, so minus 2a multiplied by 15, which is equal to 9.72 the whole square. Am I right?
Yes.
So therefore my acceleration, therefore my acceleration is nothing but 9.72 the whole square divided
Over
by
30.
minus 2 multiplied by 15. Am I right?
Yes.
So when you just work out this, your answer will be minus 3.15 meter per second square. Am I right? Am I right or not?
Yeah. Yes. Teacher.
Okay, so
I'm with you.
we got the acceleration, we got the mass. So now I'm going to find the A question answer. So my F, which is equal to my mass, what is the value of mass? 1327 multiplied by my acceleration minus 3.15. When you just work
Yes.
out what you get, 4180 Newton, and you will get the answer in terms of negative. But they gave the clear picture in the question. They have to find only the magnitude.
The magnitude,
41,
which is the positive one.
the absolute value. Clear?
Yes.
So this will be the answer for the A question.
Okay.
Understand?
Teacher, one question, please.
Yes, please.
Now here we take the weight equation, which is m multiplied by g.
Yes.
It is not with our course. So if it is coming in the exam,
Brother,
you will put the equation, or I have to memorize it.
brother, listen here. Force due to gravity, which is equal to mg. Am I right?
Yes.
The weight is also, which has the formula mg.
Yes, I know.
Both are same. So force applied due to gravity is mg. The weight applied on the body is also mg. So both are same. That's what we are just using this equation here.
Teacher, force of gravity equal to weight.
Force, you mean like this? Wait.
الوزن.
Force due to gravity is nothing but.
Yes.
Clear?
Yes.
Okay. So let's go for the second question. What is given in the second question?
The time required
The time required for the change in speed. So that means you are going to find the time. For finding the time, I am going to take the first equation. What is our first equation? V, which is equal to V naught plus AT. Am I right?
Yes.
Yes.
What is my initial? What is my final speed? My final speed is 0. My final speed is 0. What is my initial speed? 9.72. Am I right? And what is my acceleration? What is my acceleration? Minus 3.15. And time we are going to find. So what I am going to do? I am going to move this term to the left hand side. So what you will get? 3.15 t, which is equal to 9.72. Am I right?
Yes.
Therefore, my t, which is equal to 9.72 divided by 3.15, which gives you the value of 3.09 second. Am I right?
Yes.
So the second question answer is 3.09 second. Clear?
That's until it stop, teacher.
Yes. When it
Okay.
stops up to 15 meters, how much time it takes? When you apply the brake, it reaches this distance of 15 meters. So for reaching this distance, how much time it takes? The car
Yes.
takes 3.09 seconds. Clear?
Yes.
Okay. Let's go for our third and fourth answer. Brother, listen, this point is very, very careful. What you are going to do? If the initial speed is doubled, the car experiences the same force during the braking. By what factor the stopping distance will occur? So that means I'm going to take my third equation. What is our third equation, brother? V square, which is equal to V naught square plus 2 into A into S. Right?
Yeah. Why we put S? Why we don't put T?
Brother, what is your third equation, brother? What is your third
Okay, but
equation?
you put
It will be coming like this. So I can just write these as V naught square plus 2 into A into, yes, because you can see here what I written
yes,
here.
yes.
What I written here.
S equal 15 meter,
Okay,
which is
so I
equal
can just
x
write
minus
like this.
x0.
It means distance, teacher, right? D.
Distance or displacement. Okay.
Yes, yes, but I mixed up
Okay.
with the distance and the time.
No.
So
Brother,
I'm
you
sorry
write
for
the
this
equation very
mistake.
carefully. Write the equation very carefully. Okay.
Okay.
Okay. Now you can see I'm going to doubling the initial speed. So they clearly given in the question what you are going to do. You are going to doubling the initial speed. So doubling the initial speed means this is my initial speed. Am I right? Am I right or not?
Of course, teacher.
So I am going to double this. So doubling means 2 times. So V square, which is nothing but 2 times of V naught, the whole square, plus 2 into A into S. Am I right?
Yes.
So
But
should
teacher,
the
why we have to double it?
according to the question,
It's doubled.
they clearly mentioned you are going to doubling the initial speed. Clear?
Okay. Yes.
Okay. Now substitute the value. Better, you can just substitute the value. What is the value of the final speed? My final speed is 0. Am I right?
Yes.
What is my initial speed? 2 multiplied by 9.72 the whole square plus 2 into minus of what is my acceleration? 3.15
3.15 multiplied by
multiplied by
15.
15. Am I right? So I'm going to move this term to the left hand side. If you just move this term to the left hand side, what you will get?
You get 2 multiplied by 3.15.
So that means that this is better. You can just listen here. So what you will get, brother? Could you please tell me what's the answer?
I don't have a calculator, teacher. I'm sorry.
Okay. That means you will get better. I can do by myself. I'm just waiting for you. Okay. 2.
I'm sorry, teacher.
No issue. 2 multiplied by 9.72. 9.72 the whole square minus 2.
0, teacher. There's no value. I have to get.
Teacher,
Brother.
the last is
Okay.
15, right?
The last is 15. Yeah.
It's
Teacher, can you pass to 15?
472.
472. Subhanallah.
Point 41.
Wait. I will check the wait. I will check the answer. Huh? If I give the answer for you, you will mess up with everything. Two.
I forget the minus. Yes.
Teacher, what's the question? Third question.
If you are doubling the initial speed, what will be the answer? What will be your distance answer?
So you have to
Okay.
make,
Okay,
S,
brother, listen. I will make your life easy. First, you consider this equation. Okay. Okay.
okay.
If you put 0 there, what will happen? If you put 0, you will get V naught square plus 2 into A into S. Am I right?
Yes.
So therefore, and this is negative value. So that means everything will be negative. Am I right? So therefore, V naught square, which is equal to,
No, teacher, you made some mistake.
wait. I just first erase. Everything will be better. I can erase this.
You have make a distance with S, not 15.
Okay. Now, if you just make these as a 0, what is left? V naught square plus 2 into A into S. Am I right? We are going to find what is our S value. Therefore, my S, which is equal to, so 2 into A into S, which is equal to V naught square. Therefore, my S, which is equal to V naught square over 2A. Am I right? Because our acceleration is positive. Now you can just substitute the value. You are doubling the initial speed. What is your initial
Yes,
speed? 2 multiplied by
2.
9.72 the whole square. Am I right?
Yes.
Divided by 2 multiplied by 3.15. Could you please tell me what the answer? What's the answer? I got the answer as 59.98. If I just rounded the value 60. Am I right? So what is my S value, brother? How many times it increased? When you just doubling this initial speed, what is my distance? My distance is 60. Am I right? Am I right or
Yes.
not? Okay.
Yes.
Initially, what is your distance? 15 meter. Am I right or not?
4 multiply by 4.
So how many factors? So my S is increasing 4 times.
Yes.
When you're doubling the initial speed, my distance is increasing 4 times. Understand?
Yes.
Okay. If you're doubling the initial speed, what should be your time? Let's just go for this equation. V is equal to V naught plus AT. Our initial final speed will be 0. Therefore, 0, which is equal to V naught minus AT. Therefore, V naught, which is equal to plus AT. Am I right?
Yes.
No, wait. This is plus. Therefore,
But
my V
but
naught,
teacher,
which is
what's the connection between if we double the velocity, the first initial velocity?
my
we
brother,
have to
read the question. In the question, they clearly mentioned if you doubling the initial speed, what is your distance? What is your time?
is it number? Is it B? Okay, if the
B is the time. We already find the time value. B is the time. We already find B. C have, when you're doubling the initial speed, what should be your value? This is your C. What is my D value? My D is here.
So he is in the question. He asked about
Yes. So V
the
is equal
distance
to,
and the time if we
yes,
double
distance and
the
time.
velocity.
Yeah. So
Okay.
that means, so this becomes a 0, which is equal to V naught minus AT. And then when you just move this becomes AT, which is equal to V naught. Therefore, my T, which is equal to V naught over A. Now I'm going to double the value of this V naught. That means when you just doubling this value, what will happen? 2 times of V naught over A. Am I right? So if you substitute the value, my T, which is equal to 2 multiplied by
6.17.
9.71 over My A value is 3.15. When you substitute, what is your answer?
6.17 seconds.
Okay. Okay. What is your time previously? What is your time previously?
3.
So
It's
how many
doubled,
times? How many times it increased?
it increased 1 time.
Your times is increased 2 times. Clear?
Okay. Yes.
That will be the answer. You can see the answer. I clearly mentioned here. When you increase, when you just doubling the initial speed, how much time your distance is increased? 4 times. Likewise, if you're doubling the initial speed, how much time your time is increased?
2 times. 2 times.
This is a theory question, okay?
So I have to write
Okay.
it.
Yes, you have to
Double
write. Okay,
the
brother,
speed.
let's be okay. Okay. Up to this, I will just stop my lecture. Still, we have 2 more problems. Inshallah, that 2 more problems will be discussed later. Understand?
In Wednesday.
Wednesday, inshallah, you are going to write your quiz exam. Wait. First of all, I just stop my video lecture, and then I will give some instructions.
No. Leave it as recorded. So we will. I will ask you
Okay.
about the.
Okay, brother, listen carefully. Listen carefully. Your section is 105. Am I right?
Yes.
Okay.
Yes,
In
105.
105, you already, some students, you attend the mock test. That means the practice test. When I just check, I think out of these 29 students, 30 students, only 16 students they attended. Okay.
Yes. Okay.
And out of the 16 students, 1 student, when I just refer the class result of that exam, only 1 student, I think Mr. Muhammad Al-Wataibi. Brother, what is mentioned in your ID, you know, your internet connection is very slow. So I want to tell you some important thing. When you are when you are about to attend your quiz 1, you should follow these instructions very carefully. Brother, please, I requested, please don't take your mobile phone in your hand. If you take your phone in your hand, then it will be recorded as high percentage of cheating. So please, my kind request, don't take your mobile phone in your hand, because some students, they have the practice of taking picture of the question. If you take your phone and then take the picture, then your cheating percentage will be increased. Understand?
It makes a report about you.
Yeah, because I will get the result as some percentage. Okay, this much percentage the students, they do these things. So I will have the video, everything. So please try to avoid this. Don't take your mobile phone in your hand. And the second important thing, when you are about to calculate something, you can just keep your calculator and paper on your table, because some student, after they attend the exam, they take their camera and they show the paper and the calculator. No need to show anything. Just see the monitor, work out, give the answer. If you take your camera and then focus it on paper and calculator, then again your cheating percentage will be increased. Clear?
Doctor, they
Yes.
ask about the
Wait, I don't get it, teacher.
Wait. Okay, what is your question, brother?
they asked about it. They say to us, please show us the table and your yeah, like this.
So it asks something. Okay, if it is asked, no issue. But please don't take your phone. Okay, don't take your phone in your hand. It's a big problem for you, brother. Then I will put 0 mark for the quiz 1. If the system asks some request, for example, if the system asks your paper and calculator show, means you can just show, no problem. But please don't take your mobile phone. If you take your phone, it will be recorded as cheating.
Okay, teacher, what about if I
one by one, please.
Okay, teacher. What about if I look at the paper and the calculator?
No, nothing will happen. Nothing will happen, because I gave the option as a calculator. I gave the option calculator. So no, don't worry.
Okay, no problem.
Don't worry about your calculator, brother. I already gave the option. You can use the scientific calculator. So don't worry about these things. And please make your internet connection little bit faster. It's my advice, better use your laptop or desktop. Some students, you try to attend through your iPad. iPad option is there, but please make sure that you already download the link for the responders monitor. Clear?
Yes, but teacher, I use my iPad and I use my laptop, and the difference between them, the camera in the laptop, it's not clear. So my
Okay.
picture, it's too,
So
too dark and
so you
and
attended through your
not good.
iPad, am I right?
Yes, I attended
Okay,
through
no
my
issue, no issue.
iPad.
But before you use the iPad, please download everything properly.
Yes,
Understand?
I downloaded and he calculate my my speed. He make a speed test for the internet and it's good then.
Okay, then
There
it's
is no
okay.
problem.
Good. Okay. Oh, but it's okay. Good. But brother, and I saw some videos. Some students, you talk with your brothers and sisters while you attend the exam. Please try to avoid these things. One student, he talked with his small, I think his sister or I think brother, I think so. So please don't talk. When you just sit in front of the system, please see the question, give the answer. Understand? Understand?
Of course, teacher. Yes.
Okay. And then please make your internet connection a little bit faster, because it's very, very important, brother. If your internet will be slow, then your facial detection will be, the picture quality will be reduced, then it will be show some error. So please make sure that your internet connection must be good. And apart from that, listen carefully. I plan to give 40 minutes, but your exam duration is exactly 30 minutes. So it's very, very important. You can start doing by exactly by 40 minutes, do every arrangement, and then start workout for your quiz exam. Inshallah, you are going to write your quiz exam in the coming Wednesday period. Which period you have, brother? Third period, am I right?
Yes, 3.
Okay. Third period, once you come, you can just give the attendance, and then immediately you can go for writing the exam.
Doctor.
So the exam will be during the lecture time?
Yes, because you know what happened? I was little bit afraid because I gave the mock test, the practice test. Most of the students, they are not attending the test. So if one student you miss the exam, it's a problem for me. So we have to avoid these things. So I plan to conduct your quiz exam exactly during our class time.
Doctor.
Yes.
I forgot.
You forget, huh? Very good.
Yes, sorry.
Okay. Once you got the message, you can just send me the message through WhatsApp. I will answer you. Okay. Okay, brother, listen carefully, brother. Inshallah, every Monday from 7 to 8 o'clock, I make an office hour for your section. That means tomorrow you have the office hour at 7 to 8 p.m. every Monday.
Doctors, when we log on and Wednesday, we have the webcam. When we do the steps, it takes 5 minutes. This including in the test.
But brother, listen carefully. Wednesday we have only one period. Am I right?
Yes.
Just enter my class, give the attendance, and then go for your exam.
First we attend your class.
Yes, just enter. Just 5 minutes. I will just give some because we have 50 minutes. Am I right?
Yes.
Your duration of exam should be 40 minutes. Am I right?
Yes.
Yes.
So that 10 minutes you have to come to the class. I need the attendance. So please, brother, keep this information in your mind. Attendance is very, very important. You entered our classroom. Just stay there for 5 minutes. If I want to say something, I will just give some instruction, and then immediately you can go for your exam.
Teacher, you take attendance today.
What, brother?
Attendance, you take it today.
Brother, attendance, once you log in, everything will be recorded in the Excel sheet.
Okay.
I just simply download that Excel sheet. That's it.
Okay, so doctors, the available times of quiz, 30 minutes, right? And 10 minutes for steps.
Brother, for total Wednesday, you have 50 minutes. First 5 minutes, you can come and attend the class, and then immediately go for writing your exam. And the duration will be given as 40 minutes, but the exam duration is exactly 30. You can access 40 minutes, but the exam duration will be 30 minutes. Okay?
Okay.
Because some students, you said the adjustment, it takes some time, 5 minutes. Am I right? The camera adjustment.
Yes.
Okay, so some students he mentioned he's hungry, huh? Can I leave? Okay, brother. So please keep this information in your mind. If any information, please send through WhatsApp, and inshallah tomorrow you have the office hour. Don't forget.
Doctors, I have a question.
Now, brother, if anyone want to leave, no issue. That's it. I gave the clear picture. Don't forget about your Wednesday exam, quiz exam. Please prepare well for your quiz exam. Okay, now you can leave.
Doctors, I have a question.
Okay, please.
The theory question before when coming, it's difficult. It's come same this question in the exam.
Okay, which question you need the answer? In practice test, or which question?
Like this question we discuss about